Let us continue thermodynamics subjective numericals. First sum we will see. Here given is a equation. In the equation, what is given in the sense 5 carbon solid plus 4 hydrogen 4 hydrogens gas gives CH2 double bond CH3 CH double bond CH2. For this, we have to find a delta H. Standard heat of formation we have to find. What is the given data? What is the given data for this? Given data is a CH bond energy. CH bond energy is 98.8 kilocalories. Then hydrogen H bond H for that 104 kilocalories. Then CC bond for that 83 kilocalories. CC double bond for that 147 kilocalories. 147 kilocalories. Then carbon solid into carbon gas. Carbon solid into carbon gas for that 171 kilocalories. 171 kilocalories. Okay. So now what is the question in the sense? It is the equation. That means enthalpy of formation of this isoprene. Enthalpy of formation of this isoprene. We have to find enthalpy of formation of this isoprene. So we have written isoprene here. Product is isoprene. Reactants is what means constituent element. Okay. Now, so how to find enthalpy of formation? That we'll see. How to find enthalpy of formation? That we will see. How to find enthalpy of formation? That point we'll see. Okay. Now, enthalpy of formation is equal to what you have to do means this carbon solid we have to convert into carbon gas. Carbon solid converting into carbon gas means that is endothermic process. Carbon solid carbon into gaseous carbon is endothermic. For that energy is required. So energy required to convert carbon solid into carbon gas. How many moles? 5 moles. Okay. Then now carbon atoms is in gaseous state. Then these hydrogen molecules we have to convert into hydrogen atoms. These hydrogen molecules we have to convert into hydrogen atoms, for which we have to supply energy. Therefore, that is endothermic process. So plus endothermic, therefore plus. So energy required to convert hydrogen molecules into hydrogen atoms. Hydrogen atoms. Okay, hydrogen atoms. Here, how many moles of hydrogen molecules in the sense? 4 moles. 4 moles of hydrogen molecules. 4 moles of hydrogen molecules. Okay. Next. Now, carbon atoms is in gaseous state. Hydrogen atoms is in gaseous state. Now, these carbon atoms, that means 5 into C, 5 carbon atoms in gaseous state, 8 hydrogen atoms in gaseous state are rearranging one carbon, second carbon, third carbon, then fourth carbon, fifth carbon. Carbon atoms rearranging like this. Then hydrogen atoms, 4 into 2, 8 hydrogen atoms. 8 hydrogen atoms rearranging. 1, 2, 3, 4, 5, 6, 6, 7, 8. 8 hydrogen atoms. Now, how many hydrogen atoms are there? We will count again. Here 2, here 3, 5, here 3, 8. 8 hydrogen atoms are there. Now, after rearranging, after reorganizing, between gaseous atoms, bond formation takes place. Between gaseous atoms, bond formation takes place. Okay. Here, what had happened? Here what is given, what is taken? Carbon solid. Solid carbon we have taken. This solid carbon we have converted into gaseous carbon atoms for which we supplied energy, that is endothermic. Then what we have done? Hydrogen molecules we have converted into gaseous hydrogen atoms for which we have supplied energy, that is endothermic. Here 4, why we have written 4 means in stoichiometric equation 4 is there, that's why we have written 4. Next, now these gaseous atoms means carbon atoms, gaseous carbon atoms 5 moles, gaseous hydrogen atoms 8 moles. Rearranging like this. Now what is happening? What is happening means bond formation takes place. Bond formation takes place. Bond formation takes place. Okay. Bond formation in the sense liberation of energy. Bond formation in the sense liberation of energy. Liberation in the sense exothermic. So I will take negative sign. I have taken negative sign because bonds are producing in the sense energy is liberated, that is called exothermic. So I have taken negative sign. Okay. Now what are the bonds formed? That we'll see. Here carbon double bond. Here carbon double bond. That means carbon double bond 2 moles. Okay. 2 moles of carbon double bond is produced. Then carbon single bond, carbon single bond, therefore 2 moles of carbon single bond. Then CH bond, CH bond how many in the sense 8, 2, here 3, 5, here 2, 7, here 1, 8. 8 CH bonds, therefore 8, okay. These bonds are produced, these bonds producing time, energy is liberated, that is exothermic, so we have written minus. Now we will substitute energy values, we will substitute. So delta FH is equal to this 5 into carbon solid into carbon gas. For that how much? 171. 171 plus 4 into hydrogen molecules into hydrogen atoms. For that how much? Here given 104. That 104. Okay. Minus this 2 into CC double bond. CC double bond energy is how much given? 147. 147 plus 2 into CC bond. CC bond energy is given 83 plus 8 into CH bond. CH bond energy is given 98.9. Okay, let us simplify. We will get enthalpy of formation. Enthalpy of formation of what in the sense isoprene. Enthalpy of formation of isoprene we are getting. Okay. So we got enthalpy of formation of isoprene. Okay. Next, let us go to next sum. The dissociation energy of CH4. The dissociation energy of CH4. The dissociation energy of CH4 is 360 kilocalories per mole. 360 kilocalories mole and of ethane is 620 kilocalories per mole. 620 kilocalories per mole. Calculate CC bond energy. Calculate CC bond energy. Okay. Calculate CC bond energy. We have to find it. Sir, okay. Now, first point, what is given means dissociation energy of CH. Dissociation energy of CH4 means what? That we will see. Dissociation of CH4. Dissociation energy of CH4. Sir, now we will take CH4, we will take because which is undergoing dissociation means CH4 is undergoing dissociation. So we will take methane in the left side. Methane will exist as gaseous state. Physical state of methane is gas. Okay, we have written gas. Okay, it is undergoing dissociation. Sir, dissociation means what? Breaking. Breaking means what? It will convert into what? Dissociation in the sense we can say CH3 plus H. It is called dissociation. CH2 plus H. This is also called dissociation. CH plus H. This is dissociation. C plus H. This is also dissociation. Everyone is called dissociation, no? Sorry, okay. Which we have to take? Sorry. For that, no clue is given. Okay, let it be. So out of these four, we have to take any one. For that, which we have to take, we must know it. Sorry. Now, the first point is given. The dissociation energy of CH4 is 360 kilocalories per mole. Okay. So four things we have written. Four possibilities we have written. Okay. And of ethane, ethane is 620 kilocalories per mole. Okay, ethane formula C2H6, it is gaseous state. Ethane formula C2H6, it is in which physical state? Means gaseous state. It is undergoing dissociation. And of ethane, dissociation, it is also dissociation. This is undergoing dissociation in the sense CH4 plus CH2. Like this, many things we can write. One thing we can write even like this also we can write. It is gas, it is gas. Here also gas, gas we can write. So many things for ethane also we can write, many things we can write. Dissociation energy of ethane in the sense many things we can write. Sir, which we have to take? Many forms we can take. Dissociation of ethane in the sense it can dissociate in any manner. So which it is dissociating into so and so. That is it given? Not given. So it is dissociating into what? That point not given. Sorry. Now what they are asking us to find? Calculate CC bond energy. CC bond energy we have to find. CC bond energy in the sense as per the sum for ethane, because in ethane only CC bond is there. In methane not there. Methane only one carbon is there. How CC bond will be there? Sir. So CC bond energy we have to find in the sense for ethane only possible. Sir. So for ethane we have to find CC bond energy. Okay. So now for ethane we have to find CC bond energy we have to find. Sir. Now bond energy, bond dissociation energy. Two things are there. Bond energy is there. Bond dissociation energy is there. What is the difference between them? Dissociation in the sense breaking of bond, that is endothermic. Formation of bond in the sense liberation of energy, exothermic. Sir, formation of bond means exothermic, breaking of bond means endothermic. What about magnitude? Magnitude will remain same, either break or form. Breaking of bond means endothermic, formation of bond means exothermic. That only difference, but magnitude of energy is not different. Sorry. So here bond energy in the sense we can say formation of bond, otherwise dissociation of bond. Anything we can say. Dissociation of bond means endothermic, formation of bond means exothermic, but magnitude remains same. So any one we can say. Okay. So ethane we will take here. Ethane CC bond energy only they are asking, no. Therefore we will take ethane. Okay. Let us take ethane. Ethane structural formula we will write. Ethane structural formula is this. In ethane, two carbons are there. Between two carbons, single bond is there. Ethane physical state is gas. Now we want CC bond energy. That means let us break CC bond. Okay. We have broken CC bond. So CC bond we have broken. What about CH bond? CH bond shall we break or not? We want CC bond in the sense CH bond should not be there. That is the meaning, no? We want CC bond in the sense CH bond should not be there. That means CH bond also break it. Sir, we will break CH bond also. Therefore, 6 hydrogen atoms in gaseous state will get. Another thing is bond energy or bond dissociation energy means left side and right side gas must be there. Left side gaseous substance, right side also gaseous substance only should be there. Sir. So now we can say here we can say let us dissociate everything. Here let us dissociate everything. So all the CC bonds breaking. Therefore, we are getting 6 times gaseous hydrogen atoms. 6 times gaseous hydrogen atoms we are getting. Let us break CC bond. 2 times carbon in gaseous state we are getting. 2 times carbon in gaseous state we are getting. Okay, sir. For this process, what is the delta H? We will see. For this process, for this step, delta H is equal to what in the sense? What we'll see. Here it is a reactant side, left side is there. If you break the bond here, if you break the bonds, then you will get right side. In the left side, if you break the bonds, you will get right side. Sir, to break the bond, what we have to do? We have to supply energy, that is called endothermic. Sir, what bond shall we break? CH bond. How many CH bond we have to break? 6 CH bonds we have to break. That means 6 times. CH bond 6 times present. For that we have to supply energy, that is called endothermic. Okay. Then we have to break even what? CC bond. Okay. Let us break CC bond. For breaking CC bond, we must supply energy, that is endothermic, so plus. So right side we got. If you break the bond, they will convert into gaseous atoms. So gaseous atoms are produced. Therefore, for this process, delta H is what means 6 times bond energy of CH plus 1 time bond energy of CC. Okay. What they're asking us to find? They're asking us to find CC bond energy. They're asking us to find this. We have to find this one. That means we must know delta H and this. We must know delta H for this process. And we must know CH bond energy. Correct or wrong? So we should know what is the delta H for this process. For this process, what is the delta H? That we should know it. Then CH bond energy also we should know it. Then only we can find CC bond. CC bond energy we can find. So we will see the given data. So given data we will take. One data is given dissociation energy of CH4. Sir, CH4 we have taken. This is undergoing dissociation. What are the possibilities? Means these are the possibilities. Let us take this possibility. Let us take. Okay. Why? Because we want these two data. We want these two data to find this. So whether we are getting these two data from given data or not, we have to check for that case. Okay. So let us take this possibility. Therefore, I will take that one. Okay. Remaining things I am not taking. Remaining things let us leave. Okay. So remaining things let us leave. We will take the last one only. We will take. Okay. We are taking the last one we have taken. And wantedly we have taken like this. Remaining things we have neglected. Sir, we have taken like this. We have written step wantedly like this we have written. Sir, now this CH4, how it will be there? This structural formula will write. This CH4 structural formula is like this. It is gas. Now, if we break all the CH bonds, then you will get this. If you break all the CH bonds, then you will get this. This process we can call it as a dissociation. It is not wrong. This step we can call it as a dissociation. For this dissociation, what is the energy required? What is the energy required in the sense how much they said means 360 kilocalories per mole. So for 1 mole of methane to undergo dissociation, this much energy is required. So 1 mole of methane undergo dissociation by taking 360 kilocalories of energy. That means in this process 1 mole of methane is undergoing dissociation. So for this process, what is the delta H? 360 kilocalories. Okay, because 1 mole of methane is undergoing dissociation. 1 mole of methane on dissociation gives gaseous carbon atoms and gaseous hydrogen atoms, for which what is the energy required in the sense 360 kilocalories energy is required. Okay. Sir, now we know delta H of this step of this process. We know wantedly we have taken dissociation like this. Okay. Remaining steps we have not taken. Why we have not taken, that also we have to see. Okay. Now in this process we will see delta H for this process equal to In the left side, what you have to do means we have to break the CH bond, then you will get right side. How many CH bonds we have to break means 4 CH bonds we have to break, for which we have to supply energy, therefore it is endothermic. Okay. Now right side is gaseous atoms, that's what we got from this left side. Okay. Now this is equal to how much in the sense 360 kilocalories. Now we will take average bond energy of CH, we will see that is equal to 360 by 4 kilocalories. So we got a CH bond energy, we got average CH bond energy, we got it. So here we will see in this one we want CC bond energy, we want, that means we have to substitute CH bond energy and delta H for this process. For this step, delta H we have to substitute and CH bond energy we have to substitute. So it is a given data. It is 360 kilocalories is given data. From 360 kilocalories, we got average CH bond energy. This average CH bond energy, let us substitute here. Average CH bond energy, let us substitute here. Okay. So average CH bond energy is how much? 90 kilocalories that we have substituted. Okay. Now we have to find this CC bond energy. We have to find CC bond energy. We have to find. To find CC bond energy, one data we got, CH bond energy we got it. Now we want delta H for this process. For this process, delta H, if you know, we can find CC bond energy. Okay. So we want delta H. Now here given is a ethane undergoing dissociation. So ethane is undergoing dissociation means ethane is left side. It is on dissociation. Many possibilities are there. Among them, one possibility is what means this is one possibility. Let us take wantedly this possibility. We will take remaining possibilities. Let us neglect. Okay. So we are taking in this dissociation of ethane. Wantedly, we are taking one possibilities. Remaining possibilities we are neglecting. Okay. Remaining possibilities we are neglecting. We have taken wantedly like this possibility. So ethane gas on dissociation gives gaseous carbon atoms and gaseous hydrogen atoms. Wantedly we have taken like this. For this process, delta H is how much means 620 kilocalories per mole. So 1 mole of methane on dissociation absorbs 620 kilocalories of heat. Like this we have taken wantedly. Now this process delta H and this process delta H same, therefore we will take this is a 620 kilocalories, here also 620 kilocalories will take. Why we have taken wantedly the dissociation of ethane like this? Why can't be other steps? Other steps if we take, we cannot find CC bond energy. So we have to go like this only. As per the given data, it is the direction, there is no other way. So that only we have gone like this. Sorry, then now we can find a CC bond energy, we can find that is how much in the sense 80 kilocalories. Okay, we got a CC bond energy, that is how much in the sense 80 kilocalories, we got it. Okay, let us go to next sum. The heat of combustion of acetylene, the heat of combustion of acetylene, the heat of combustion of acetylene is 312 kilocalories. Is 312 kilocalories. If heat of formation of CO2, if heat of formation of CO2 and H2O or 94.38, 94.38 and 68.38 and 68.38 kilocalories respectively. Calculate CC triple bond energy. Calculate CC triple bond energy. Calculate CC triple bond energy. Given that heat of atomization of carbon, given that heat of atomization, given that heat of atomization of carbon and hydrogen or 150 and 51.5 kilocalories respectively, and CH bond energies, and CH bond energies 93.64 kilocalories. 93.64 kilocalories. Okay. So now let us see the sum how to find. Okay. First we will write the given expression. We will write. So here enthalpy of combustion of acetylene is given. Enthalpy of combustion of acetylene. Okay. For that we will write equation combustion of acetylene. So we will write acetylene in gaseous state plus oxygen in gaseous state. Carbon combines with oxygen to give carbon dioxide. How many times? Means 2 times. Hydrogen combines with oxygen to give water. Okay. Now let us balance the equation by keeping acetylene as 1 mole. Now oxygen is 2 to the 4 plus 1 5. Therefore 5 by 2 will write. For this delta H is given. That is how much? Means 312 kilocalories. Now see, acetylene is undergoing combustion. Combustion means burning. Burning in the sense heat is liberated. That means exothermic. So we must write negative sign here. Though they have not given in the sum, we have to write minus. Okay. Next, enthalpy of formation of carbon dioxide. Enthalpy of formation of carbon dioxide. So that means carbon dioxide is produced. So left side we have to write constituent elements. We have to write graphite solid plus oxygen gas. Now it is balanced. For this, it is enthalpy of formation of carbon dioxide. How much given in the sense 94.38 given. 94.38 given. Okay. This equation, you see, it is called enthalpy of formation of carbon dioxide, no doubt. And also you see, carbon plus oxygen gives carbon dioxide in the sense graphite is undergoing combustion. Therefore, it is called combustion reaction. Graphite is burning with oxygen. Therefore, only we are getting carbon dioxide. It is combustion of graphite. Combustion of graphite in the sense graphite is burning. Graphite burning in the sense it will liberate heat. Therefore, it is exothermic. So, we must write negative sign here. Okay. Actually, they have not given in the sum. Actually, so though they have not given, we must write. Because graphite is undergoing combustion in the sense certainly it will liberate heat, in that there is no doubt. So, we have to take negative sign. Okay. Sir. Next. Enthalpy of formation of water. Water given 68.38. For that equation we will write formation of water. So water we will write in the right side, we will write in the liquid state. Water, for water, if they have not mentioned physical state, we have to take liquid. Okay. If they mention what physical state they are saying, that we have to write. Okay. The right side we will write, left side we will write constituent elements in standard state we will write. Okay. So I have balanced this one. So it is called enthalpy of formation of water, that is given 68.38 kilocalories. It is also it is also called, it is nothing but what means combustion. Hydrogen combined with oxygen to give water. Therefore, a hydrogen is burning. Hydrogen is undergoing combustion. Combustion in the sense exothermic. Therefore, you write minus here. Exothermic, write it. Okay. Then what they're asking us to find, you see, calculate CC bond energy. CC bond energy we have to find. CC bond means a triple bond between carbon atoms. Triple bond is there. That bond energy we have to find. Set. Now heat of atomization of carbon. Atomization of carbon in the sense what? Atomization in the sense what is given that you have to convert into gaseous atoms. Atomization in the sense the given thing you have to convert into gaseous atoms. Set. Okay. Atomization of carbon in the sense you are converting that into gaseous carbon atoms. Okay. Atomization of carbon in the sense the given thing you are converting into gaseous carbon atoms. What is the given? Carbon is given. Okay. Sir, carbon is given in the sense right side we know, because given thing we have to convert into gaseous atoms, that is called atomization. So atomization of carbon means in the right side gaseous carbon atoms, that in that there is no doubt. What is left side? Left side what? Left side is carbon only, no doubt, because we are getting carbon in the sense left side carbon must be there. What is the doubt? Which physical state? What is the physical state of carbon? We have to take graphite solid, we have to take, or a diamond we have to take, which we have to take, or gas we have to take, which we have to take. Sir. For that, here given is 150 kilocalories given. Delta H given is 150 kilocalories given. 150 kilocalories given in the sense energy is utilized in this process. In this process, energy is utilized. Energy is utilized in the sense either absorption or liberation. How to know it? Because already they have in these places and all negative sign must be given, that and all they have not given. So whether this 150 given is here a sign they have not given in the sense positive sign we can take, but we are getting doubt from these points. From these points we are getting doubt here also, whether it may be negative or what. It may be exothermic or what. Like that also we are getting doubt. Sir, they have given positive, that means endothermic, but we are having doubt. Maybe it is a negative exothermic, like that we are having doubt. Sorry, okay. So now we will see the word atomization. Atomization means what? Given thing we have to convert into gaseous atoms. Given thing we have to convert into gaseous atoms means given thing one possibility solid, one possibility liquid, another possibility gas. Carbon gas into carbon gas means we need not give energy 150. 150 we need not give. Therefore, this gas possibility we can neglect. So another possibility what? Solid and liquid. Solid carbon into gaseous carbon, endothermic. Liquid carbon into gaseous carbon, that is also endothermic, there is no doubt. Sorry, okay. So one thing we have confirmed, it is endothermic, therefore positive. Okay. Next step. Now it is solid or liquid. Now, regarding carbon, anything is mentioned? Anything is mentioned? Is it solid carbon or liquid carbon? Anything is mentioned? Nothing is mentioned. So, nothing is mentioned means normally it will exist as what? That we have to see. Normally, in the sense solid, therefore solid you take. Otherwise, they will mention something, some idea, something, some clue will be given. So, nothing about carbon is mentioned. Therefore, normal thing we will take solid. Okay. So, solid we have taken. Next. In the carbon solid, in the sense many possibilities are there for carbon. Many allotropes are there for carbon, graphite, diamond, fullerenes, coal, coke, like this, charcoal, wood charcoal, sugar charcoal. Many things are there, which we have to take. Amorphous carbon or crystalline carbon, which we have to take. Nothing is mentioned regarding that also, nothing is mentioned in the question. So, in that case, standard state you take, that's all. Nothing is mentioned means go for standard state. Okay, therefore graphite we have written. Sir, this is over. Next, heat of atomization of H. Heat of atomization of H is 51.5 kilocalories. Sir, atomization of what means hydrogen. Therefore, right side what means gaseous hydrogen atoms. In that there is no doubt. Atomization in the sense given thing you have to convert into gaseous atoms. Okay, what is given that you convert into gaseous atoms, that is called atomization. Therefore, right side is gaseous hydrogen atoms, that is confirmed. For that delta H is given. How much means 51.5 kilocalories given. 51.5 kilocalories given for that side. Now what shall we write left side? Left side what we have tried means no doubt we have tried hydrogen, in that there is no doubt. Right, this side what we have to write means hydrogen we have to write. Hydrogen in the sense which physical state? Solid shall we write, liquid shall we write, gas shall we write? We cannot write gas because delta H they have given. So gas possibility we can leave. Okay, gas possibility we have left. Okay, because delta H is given, therefore gas possibility not there. Sir, solid or liquid? That is one doubt. Another doubt is, can we take hydrogen atoms? Is hydrogen atoms possible in solid and liquid? Think it. Naturally, how hydrogen is there? Normally, how hydrogen is there? In the atmospheric air, hydrogen is present in the form of gaseous state and also in the form of molecular form. In the naturally available gas, hydrogen gas contains hydrogen molecules in the normal condition. So hydrogen molecules only existing in the normal condition. Hydrogen gas can be converted into liquid or solid under lower temperature. If you liquefy only, hydrogen gas will convert into liquid hydrogen gas. So regarding that, nothing is mentioned. Hydrogen liquid in the sense, negative temperature we have to take. Okay, room temperature, hydrogen will exist in gaseous state only. Therefore, a negative temperature we have to take. Regarding that, not mentioned. Therefore, what we have to consider, normal condition we have to consider, otherwise standard state we have to consider. So under normal condition, hydrogen exists in the form of gaseous state and molecular form. Therefore, you write here hydrogen molecules, right? Don't write hydrogen atoms. Hydrogen atoms in solid and liquid, not at all possible. Hydrogen atoms in gaseous state is possible. Okay, but hydrogen atoms in solid and liquid, never possible. But hydrogen molecules in liquid state possible. Okay, therefore no doubt the hydrogen atoms in solid and liquid not possible, so we will neglect this. Hydrogen atoms solid in liquid not possible, so that point we will neglect it, we will remove. Now hydrogen molecules, we got a conclusion. Hydrogen molecules, left side hydrogen molecules, we got a conclusion whether it is solid or liquid or gas. That's what we want. So gas in the sense a normal condition, no doubt. Solid and liquid means negative temperature we have to take. That like that means they would have mentioned, that is not mentioned. Therefore, we have to take gas. That is only possibility. Other possibility not there. Sorry, okay. Now we have to balance this. How to balance? Okay, how to balance this one? Shall we write 2 here? Shall we write 2 here? What is the given question? We'll see. Heat of atomization of H. It is the given data. What is given? What you are taking? H you are taking. Heat of atomization of H in the sense, now what is heat of atomization? That means I will say, here say. For this, how to say means heat of atomization of graphite solid, like that we have to say. This delta H, this delta H meaning is what means heat of atomization of graphite solid. That is the meaning. That means this meaning is what? What is the heat required at constant pressure for the atomization of this graphite? That means the left side only we have to write, say no. Therefore, what you have to say for this? Heat of atomization of H2 gas we have to say for this step. For this step, how to say? Heat of atomization of H2 gas you have to say. This you multiply by 1 by 2. Why we have to multiply by 1 by 2? Because they have given H. Therefore, I am multiplying by 1 by 2. 1 by 2, if I multiply, what will happen in the sense, this 2 will get cancelled. Then I will get H. Correct? Therefore, you multiply this by half. Okay, multiply this by half. So you are multiplying this by half. Therefore, you are getting like this. 1 by 2 you are multiplying. Therefore, here 1 only. For this, what is the delta H means 51.5 kilocalories. Okay. So you are multiplying this by half. Why you are multiplying by half? Because they have given like this. H they have given. So we must multiply this by half. Then only it will become H. Correct? So we are multiplying by half. Delta H, don't multiply delta H by half. For this, half H2 gives H gas. For that, delta H is 51.5. Okay. Therefore, now we can say that the half H2 gives H gas. Delta H is equal to 51.5 kilocalories. Okay. Next, given is CH bond energy given. CH bond energy given. Okay. So using this, how to find CC triple bond energy? CC triple bond energy, how to find that we have to see. Okay. CC triple bond energy, how to find using this, sir. So what shall we do? That we will see. Now we want CC bond energy. We know what in the sense CH bond energy we know. Okay. Now let us see all these equations. If we add all these equations or if we do anything, what we will get, that we will see. Okay. Let us take first equation as it is. Second equation, what we will do, second equation in the sense, let us reverse second equation. Let us reverse the second equation and we will multiply the second equation